Put a shark and a lion side by side. Both are predators. Both can kill large prey. Both can injure a human. And both contain meat that is technically edible. But one may appear on a restaurant menu. The other almost never does. At first, the obvious answer seems to be danger. A lion is too risky to hunt. But sharks are dangerous too. Then the answer seems to be poison. Predators sit high in food chains. So perhaps their bodies collect things humans should not eat. But people still eat tuna, squid, alligator, and shark. So the real dividing line cannot simply be predator or prey. Something else decides which animals enter our food system. And the answer only becomes clear when we follow the journey from a wild animal to a human plate. Begin with the shark. A shark is not easy prey. Many species grow slowly, mature late, and produce relatively few young. That makes heavy fishing difficult to sustain. So sharks did not become food because they were harmless, abundant, or easy to replace. They became food because humans found a way to place some of them inside a larger system. Boats were already leaving shore. Fishers were already using lines, nets, hooks, and harpoons. Ports were already receiving seafood. Traders were already moving fish from the coast to markets. A shark could be targeted deliberately. It could also be caught during another fishery. Either way, once it reached the deck of a boat, the problem changed. The eater no longer had to confront the predator. The predator had entered a chain of tools, workers, transport, processing, and trade. That chain could operate again the next day. And that repetition matters more than it first appears. A rare meal can come from almost any animal. A regular food source cannot. It must appear again next week, next month, and next season. Only then can buyers, sellers, and habits form around it. Now try to build the same chain around a lion. First, you need to find one. Lions do not move through the landscape in dense schools that one piece of equipment can harvest. Large predators exist at lower levels of abundance because the animals beneath them must support them. Energy is lost at every step through a food web. That does not make lion meat low in calories. It means a landscape needs a great deal of prey before it can support a much smaller number of lions. So before the hunt begins, the supply is already limited. Then comes the approach. A hunter must locate the animal, move close enough to kill it, survive the encounter, and handle the body. And after all that risk, another lion may not be available nearby for a long time. One successful hunt does not create a dependable food source. That is the first hidden test. Edible is not enough. The animal must be obtainable repeatedly. But perhaps humans could solve that problem by raising lions. People learn to manage cattle, sheep, goats, and pigs. Why not keep lions in enclosures and turn them into livestock? Because captivity is not the same as food production. A single lion can be tamed or kept behind a barrier. Livestock must do something much harder. They must tolerate regular human control. They must feed, breed, and live in conditions humans can manage across generations. And they must do this at a cost that makes the meat worth producing. Large carnivores are poor candidates. They require animal-based feed. They can be dangerous to keep. And managing many of them would mean feeding meat to predators in order to produce more meat. A lion can live in captivity. That does not make lion farming an efficient way to fill a market. This creates a strange contrast. Sharks are not domesticated either, yet some still become food. Why? Because humans do not need to control the breeding of every animal they eat. Some animals can be raised, others can be harvested, but there must be a repeatable route from the living animal to the buyer. Some sharks entered that route. Lions never entered one at any ordinary scale. That may sound like the answer, but it creates another problem. If sharks can enter a food system, why are some still considered risky to eat? This is where toxins matter. In aquatic food webs, mercury can enter small organisms, move into fish, and become more concentrated in some long-lived predators. That is why shark and certain tuna can appear in high mercury guidance. But this is not a simple predator rule. Squid are predators too. So are many smaller fish. Their contaminant levels are not identical. The risk depends on the species, its age, its environment, and what it has eaten. Predation can increase exposure to some contaminants. It does not turn every predator into poison. Parasites create a similar complication. Some wild carnivores can carry trichinella in their muscle tissue. Humans can become seriously ill after eating infected meat that was not cooked properly. Bear, wolf, wild boar, and other wild animals can be involved. That risk is real. But again, it does not draw a clean line between predators and prey. It tells us that some animals require careful handling, processing, and cooking. It does not explain the entire menu. And even after an animal passes the practical and biological tests, humans may still refuse to call it food. That is where culture becomes powerful. People learn food categories long before they understand ecology. A squid may look like dinner in one household. A lion may represent danger, pride, wildlife, or conservation. Markets reinforce those meanings. Religions and traditions reinforce them. Laws reinforce them. Biology may make humans cautious around decay, contamination, and unfamiliar flesh. But culture teaches us which animals belong on a plate. Now the shark and the lion can be compared clearly. The shark is dangerous. Some species reproduce slowly. Some carry high contaminant loads. Some fisheries are not sustainable. Yet fishing technology can still capture certain sharks, bring them to shore, process them, and sell them through an existing seafood market. The lion faces a different wall at nearly every step. Its natural supply is limited. Finding and taking one is difficult and dangerous. It does not fit an efficient livestock system. It does not enter an existing harvest system in large numbers. And modern conservation laws make routine exploitation even less realistic. The lion does not fail one test. It fails several at once. So the animals on a menu are not simply the animals humans decided tasted good. They are the survivors of an enormous practical test. Can people obtain the animal repeatedly? Can they manage the danger and cost? Can they move it through processing and trade? Can the population replace what is removed? Can health risks be controlled? And will a culture accept it as food? Some sharks pass enough of those tests to reach a plate. Many also fail the sustainability test, which is why their presence on a menu does not automatically mean the system is wise or safe. Lions rarely pass enough tests to become routine food. And this reveals something larger about every meal. The animals we eat most often are not simply the animals humans could kill. They are the animals that could support repeated demand. Many edible species never crossed that threshold. They remained occasional catches, local traditions, or animals valued in other ways. So the difference between a shark on a menu and a lion outside, it is not one mysterious chemical hidden inside the meat. It is the entire path surrounding that meat. The ecology that produces the animal, the technology that captures it, the risk of obtaining it, the ability of the population to recover, and the human decision to treat it as food. A wild animal does not become dinner merely because its flesh is edible. It becomes dinner when humans can build a dependable path from that animal to the plate.